Ancient India made remarkable contributions to the field of science, laying foundation for many disciplines that continue to shape modern knowledge. The integration of science and philosophy was a hallmark of Indian thought, leading to advancements in the areas such as mathematics, astronomy, medicine, and metallurgy. The use of numbers 1 to 9, multiples of 10, and maximum number 100,000 was mentioned in Rigveda. Krishna Yajurveda has powers of 10 until a trillion. Shilva Sutras, part of one of the Vedanga called Kalpa, dated back to 2000 BCE to 600 BCE, has principles devised to create many geometrical shapes. The main purpose was to construct fire altars, and important to note is that tools used were just a rope and a pin or a stick. The ancient Vedic people have mastered basic geometry and were able to create different shaped fire altars like tortoise, falcon, interestingly the same surface area of 7.5 Purusha, where one Purusha is equal to length of human hand from tip of his hand raised straight up in the air to his feet on the ground. The fire altar will have a total of 5 layers, and in each layer shape of bricks were of different geometrical shapes, and all layers have similar surface area. Construction of perfect square and multiples of that square for bigger fire altar constructions was mastered by Vedic people. Baudayana wrote a Sulba theorem similar to Pythagorean theorem, probably centuries before Pythagorean. And Baudayana was the first mathematician to propose approximate value for pi. The proper metrological system for measuring linear systems was in place. IBC had a calibrated weight standards, bricks with 4 to 2 to 1 ratio, reflecting the use of binary number system 5000 years back, and still being used in computer devices like RAMs with memories like 2 GB, 4 GB, 8 GB, 16 GB, etc. In India, time was measured using Gati Yantra, water clock, where Gati stands for a basic unit of time. A properly calibrated hole was present at the bottom of a smaller cup, and it was placed on a big water tub. The hole was calibrated that it takes 24 minutes for the cup to fill up. Each day had 60 gatis, each gati being 24 minutes. Perhaps the greatest gift or contribution of India to the world of mathematics is the decimal place value notation. It was first found in a text written by Buddhist Vasumitra during 1 CE, followed in a Jain book, Loka Vibhaga, and first inscription of decimal place value notation was found at Sankheda, Gujarat, dating back to 594 AD. The most famous mathematician name anyone hears from India is undoubtedly Aryabhatta. He is credited with invention of zero into mathematical calculations, further development of decimal number system, number theory, trigonometry, algebra, and astronomy. He proposed approximate value of pi to 3.1416. He gave formulas for area of triangle, calculation of square and cube roots. Aryabhatta also proposed some wrong calculations with respect to volume of sphere. Later on, Bhaskara II in 12th century AD gives the correct formula for the volume of sphere. Aryabhatta mentioned circumference of Sun as 4 times of Earth, but modern calculations show it as 109 times that of Earth. Aryabhatta proposed correct value for circumference of Earth with a decent approximation to modern calculations. Brahmagupta is one of the fathers of modern algebra, authored a book called as Brahmasputa Siddhanta. He proposed Bhavana algorithm for second order indeterminate equations, gave general solution for linear and quadratic equations. His major contributions were to algebra, arithmetic, trigonometry, and astronomy. Many of his contributions were discovered by European mathematicians almost a millennium later, showing the prowess of Indian mathematicians. Brahmagupta first gave the concept of gravity and used the word Gurutwakarshanam during 628 CE. He calculated value of pi with less than 1% error. One of his significant contributions is the use of negative numbers, using 0 as a figure in mathematical calculations. Bhaskara I was also one of renowned mathematician from India and invented Hindu-Arabic numbers and Hindu-Arabic decimal system. Mahavira, a Jain mathematician around 850 CE, authored a book called Ganita Sara Sangraha, gave formulas related to algebra, provided method for LCM calculation centuries before John Napier. Bhaskara II or Bhaskaracharya was undoubtedly the greatest mathematician of medieval times in India. He has made a great list of contributions to the field of mathematics. Bhaskara II's book Siddhanta Siromani has four parts: Leelavati, Bijaganita, Grahaganita, and Goladhyaya, dealing with arithmetic, algebra, mathematics of planets and spheres respectively. Bhaskara II gave the first general method for finding the solution to so-called Pell's equation, Piofanton equations, many centuries before the European counterparts like Pell, Euler, Pierre de Fermat. Bhaskara II gave preliminary concepts to mathematical analysis, differential calculus, integration, coefficients. Invented Chakravala, a cyclic method to solve algebra, which was later popularized by Europeans as inverse cyclic method. Broadly, he made contributions to arithmetic, calculus, trigonometry, astronomy, and engineering. A remarkable phase in medieval Indian mathematics was the Kerala school of mathematics founded by the great Madhavacharya. First in the world, he invented the infinite series related to trigonometric functions. Madhava and his peers' work led to the field of calculus in the mathematics. He made significant contributions to trigonometry, geometry, and algebra as well. Many centuries later, his infinite series was further improved and popularized as Gregory series by foundational work from mathematician named Gregory. Significant Indian mathematical knowledge moved into Europe via the Arabs. During 810 CE, Caliph Harun al-Rashid and his son al-Mamun were credited for the establishment of House of Wisdom. Al-Khwarizmi was located at House of Wisdom, compiled Indian mathematical texts, translated them into Arabic. His Latinized name later became algorithmi, giving actual name to mathematical principle called as algorithm. Indian decimal place value notation was called as Hisab al-Hind. A landmark to mention is the introduction of Indian number system into Europe by Adam Rees in 1522 for mathematical calculations. It became an overnight sensation in Europe, and Roman numbers previously used for mathematical calculations were totally replaced by Indian numbers for calculations. Astronomy was another field where India had made significant contributions, contributing starting from Vedic age. Vedic works like Aitareya Brahmana, Chandogya Brahmana clearly state that sun never sets or rises. He is all alone in the middle. They used to believe sun to be stationary. Aitareya Brahmana 733 mentions sun is ever vigilant and never sleeps, and yet being smallest of all worlds was too mentioned in Aitareya Brahmana. Taittiriya Samhita, Maitrayani Samhita, Kataka Samhita clearly mention 28 nakshatras or constellations along with Abhishek. Ancient astronomical text, one of the 6 Vedangas called Jyotishya, mentions 27 constellations or nakshatra mandalas, 5-year yugas, rules for lunar calendar, etc. Lagada mentions that it takes around 26,000 years for the axis of Earth to take a complete 360-degree rotation of the celestial constellation spheres. Lagada's Vedanga Jyotishya, dated back to 1400 BCE, mentions about equinoxes, 6 seasons, and solstices. First ever recorded solar eclipse in entire world was in Rigveda 5th Mandala. Rigveda says sun is struck with darkness by an asura or demon. Vedas mention 12 lunar months with 30 days each and addition of an extra month every 6 years to synchronize lunar and solar calendars. Shatapatha Brahmana has calculation of number of full and new moons in 15 years to be as 360. Total number of muhurtas per year were mentioned to be 10,800, and same number of bricks were actually used in mega fire altar constructions with vast sizes and a height equivalent to humans. Aryabhatta wrote, Earth is a rotating sphere and is the reason for days and nights. Brahmagupta rejected this idea and made some harsh comments saying, if Earth rotates, how can birds flying in the morning can find back home during the evening as Earth has rotated 180 degrees already? But Aryabhatta was right on this topic. Brahmagupta was actually wrong. If one checks the time scales across the globe, it is pretty clear that Indians had concepts of time and space never ending, cyclical nature of time, concept of infinity, concept of yugas spanning millions of years. On the other hand, other religions like Judaism, Christianity have a max 6,000 year time bracket. Metallurgy is another area where ancient Indians have excelled. First evidence of copper bronze was found in Mergar around 6000 BCE, evidence of copper metallurgy around 4500 BCE. Indus Valley civilization had ancient lost wax technology to build bronze statues. For example, Dancing Girl dated back to 4500 BCE in addition to many copper tools that were excavated. Ancient lost wax technology works as follows. First, the desired statue was made with wax, covered with clay, and then subjected to extreme heats, where the wax melts away, leaving the hard clay with desired pocket, rendering the shape of the statue. Then, molten bronze is poured into the clay pocket and cooled. Hard clay outer layer was broken away to obtain the desired bronze statue. The same method is still in practice in southern India, Tamil Nadu, to build bronze statues. One more famous example is the copper statue of Buddha currently in British Museum, weighing 500 kg, measuring 2.3 meter into 1 meter in dimensions and with close to 7 feet in height. First in the world, extraction of zinc was mastered by Indians in Zawar, Rajasthan, with timber found at the site carbon dated back to 400 to 300 BCE. During medieval times, zinc was produced on multi-ton or industrial scale. Persians were not successful in zinc extraction due to their open-air reduction method, whereas Indians use closed retort reduction procedure with inverse condensation method to successfully isolate zinc for the first time in the world. Fully metallic mirrors, elegant and scientifically more efficient, are the Aranmula mirrors. It is made by a family tradition of workers in Kerala who secretly close guard the actual composition till date. Perhaps the world famous contribution from India is the wood steel, dated back to at least 500 BCE. Known for its high carbon content, these wood steel swords were gifted to Alexander the Great by King Porus after the war compromise in 4th century BCE. The same wood steel was exported by the Arabs during 6th to 8th century CE, were popularized as Damascus swords and used by the Arabs and Europeans. The Hindus excelled in the manufacture of iron, and it is impossible to find anything to surpass the edge of Indian steel, said Al-Idrisi. Indian wood steel is far superior to European steel, unparalleled in several aspects, said Robert Hadfield. Design and production of multitude variety of coins by various empires was a common thing in India as anywhere in the world. A metallic wonder across the global tourist till date is the iron pillar of India, forged during 5th century CE, Gupta period. Till date, it is corrosion resistant due to its high phosphorus content. Now, let's talk about architecture. Starting from the Indus Valley civilization, with proper construction of urban cities dating back to 5000 years, to the mind-boggling monolithic temple at Ellora Caves, the supreme artistic features of Hoysala architecture, and the architectural marvel Konark Sun Temple, are few examples reflecting the exemplary capabilities of Indian artisans. Linguistics. Panini, the father of linguistics, wrote for the first time in the world a language model with a proper 4,000 rules that are algorithmic and suit the current generative AI models in helping the machines understand language strings unambiguously. Noam Chomsky, father of modern linguistics, his language model is similar to that of Panini's language model, with Panini composing these rules 2500 years back. You can sing all 4000 algorithmic rules of Panini in just 2 hours and was saved via oral tradition till today. Other significant areas of contribution are yoga, a proper method that helps humans achieve physical and mental balance via many physical exercises, breathing techniques, and meditative practices. Yoga is practiced by millions of people across the globe every day. Medicine. The father of surgery, Sushruta, was an exemplary surgeon and invented many surgical methods. His book Sushruta Samhita details about various diseases close to around 1200. He invented around 120 surgical instruments. Sushruta is famous for his rhinoplasty surgery, where you can attach a nose that was cut as a punishment, a classical method of punishment used in ancient medieval India for people committing infidelity or any heinous crime. Charaka was a famous Ayurvedic physician and devised many useful Ayurvedic medicines or treatment methods that are used until today by many local populations in India. Apart from these areas, significant contributions were made in the areas of natural sciences and physical sciences like chemistry, etc. by ancient Indian scientists, with only a selected highlights mentioned in this video. The most important thing I would like to mention is that the ancient and medieval India had made key groundbreaking contributions in various fields of science, which is totally missing nowadays from India. Even though scientific metal in India is no short to any country across the globe, an ecosystem of encouraging novel ideas with even lower chances of success is very crucial to the country's scientific progress. Ancient India was coming up with completely out-of-the-box strategies and solutions to challenging problems and used to provide first-in-the-world class of solutions when Europe and America were in their dark ages. Now the tide has turned completely opposite, with India ended up being a stagnant water pot for science and only singing glories of the past. The reason for the current situation is both due to past 1,000 years of invasions and wars, strategic annihilation of key economic backbone industries of India, especially by the British, and other reasons being the corrupt political system, limited investment on research and development, with less than 1% of Indian GDP spent on R&D, leading to lack of world-class research facilities being spread across the country. Brain drain is a serious problem faced by India, where some of its most talented scientists, engineers, and researchers migrate for better opportunities. Centralized bureaucratic hurdles, broken education system with limited creativity and critical thinking, coupled with socio-economic challenges such as poverty, illiteracy, and public health issues, pose a serious challenge. Despite these conditions, India has made notable progress in science and technology. Becoming a scientific powerhouse, though, requires systemic reforms, increased investment in R&D, fostering a culture of innovation, and addressing bureaucratic inefficiencies. India has the talent and potential to achieve this status, but realizing it will require sustained commitment and strategic planning. Thanks for watching the video. Do share this video to your friends and family. Turn on the notification bell as well, and don't forget to subscribe to the channel. Thanks again. Jai Hind.